managing time series. So in Infosys, there is support for two different types of time series. There is the single time series that is used to represent continuous time series data sets. The way you would define it, you have a start time, you have a time step resolution, and the length of the data determines what the end time is going to be, right? Imagine you've got like a 5-second time resolution, you've got 5 values, you can multiply by that by 5, so you have 25 seconds of time data. So if you know what the start time is, you can calculate what the end time is. Note, this assumes that your data is continuous, so every single value you have in your array is continuous, so it's going to be the time resolution is consistent and constant. Then we have a special case which is non-sequential time series, is what it's called right now, but it defines discontinuous time series data sets where you have a direct mapping between each data point and then you have a time step associated with each data point, right? So in this example below, what we're going to do is attach a time series profile to a load within the distribution system. So in this example, again, I'm importing a distribution system and importing the distribution load class. Again, I think one thing I probably did not talk about is if you're working with distribution systems, there are nested components within the models that we create, right? So for example, in distribution load, if you print that out, I just showed you the pretty print for the bus as well, right? There are other components within this nested. And if you want to be able to add all of them automatically, just set auto add compose components to equal to true. And then if you have nested models that you haven't already added to the system, they're going to get added automatically, right? So you don't have to worry about like first adding the nested components and then adding the top layer. You can just add all of them in one go essentially. So in this example, I'm just creating an example of a load and adding it to the system, right? Next, what we're going to do is we're going to create a time series object. Once we create a time series object, all of time series objects within Infosys and within JDM have to be mapped to a component, right? To an existing component within the JDM system. Things to note: time series profiles can only be added to components that are already within the system. So first you need to add. So in this case, I added the load to the system, and then I can attach a time series profile to the load. A profile can be mapped to multiple components, and multiple profiles can be mapped to an Infosys component. So a load, for example, can have multiple profiles, and then you can have one profile that is mapped to say 10 loads. Both of them work. All right. So when you're working with time series, so the example I have here is a single time series. So you import it and I'm building it from an array. So I can say a single time series from array. You can define the data here as an array as well. Again, if you look at the data, here we support byte quantities as well, right? So if your data has units, we support those units here as well, right? Another point here is that because what we do is we map each time series to a component, we map it to a very specific property of a component, right? So the load the load model I have has an attribute called active power, and that is the variable we're going to connect this time series to essentially, right? And the idea here is that if you have the active power or reactive power or whatever, you can attach a profile to every single parameter that exists within a data model essentially, if that makes sense. So you define the time resolution and you define the start time. Once you've defined the load profile, you can then add it to a single load or multiple loads, for example, right? We have some additional parameters there as well. So profile type and profile names are additional user-defined parameters. So these parameters are actually used by Ditto. In our case, because we want to be able to map them to say in OpenDSS, we want to be able to map to a very specific kind of way, right? And then we have flags like is it an actual value, is it normalized, all of this. So what does your profile really represent? How do you want to manage it? So we do support like some manipulations as well, and you can go through the documentation. We've documented that really well within our documentation as well. So once you add, then you can call system.add time series, and this is actually going to attach the time series profile to your load within the system itself. And if this was done successfully, if I call system.info, you'll see some metadata associated with like summary of time series data as well. So in this case, we've added one component, and then you see that you have one time series within the distribution system now, right? Any questions up to this point, guys?
I have a question on this one.
Yeah.
If you're wanted to use the same time series, say solar profiles for multiple different units, is it any reason you wouldn't be able to just assign that same variable you defined as a single time series to multiple different points in the system?
You can. So for example, here I have load 1, right?
Mm-hmm.
You could just pass an array of loads here, and then it would be attached to every single load. It would be attached to the same property though, right? So it has to be attached to ActivePath.
Because when you define it, it's ActivePath.
Exactly.
Yeah.
And then when I'm writing it to Ditto, I'm going to look at the profile, and we have support in Ditto for this time series as well. So we're using it in Ditto, and we're using it in other places as well. But yeah.
In Sienna, we have this notion of time series multiplier. You can have the same time series for different components, but
So we have that support as well. Yes. Yes.
Does that get defined at this stage or at some other stage?
So we have it gets defined here as well. So we have additional fields there that you can use, and then we have flags we support we support multiple normalizers as well. So do you want to use a min-max normalizer? Do you want we have support? We have I believe 2 or 3 different normalizers that we can use, but I haven't shown all the capabilities here, but they are documented. So you can have a look at both the process documentation as well as GDM documentation for more information.
To take that one step further though, it seems like one potential use case of interest would be to have 3 different loads with the same load profile but different scaling factors.
Yeah, we support that, yes.
Okay, because it seemed like you
I just wanted to go over all the capabilities in like the most minimal way I could think of, and then go from there. All right. So once you add the time series, if you want to look at the list of time series you want to return them, you can do system.list time series, and you can define the instance of the model that you have. So for example, if I want to know what all profiles are attached to load 1, I can call this function that's going to return all the profiles that we have. In this case, it's just a single profile, but this will list all the profiles that you want to work with. One final piece, when you see it serialize, we'll get to that in a second. So when you serialize the system to disk, these profiles get exported to system name, whatever your system name is, _ time series. So wherever that JSON file exists is going to get written to, you'll see there's a folder called _ time series there as well, and that is where all the profiles get dumped as well. All right. Any questions before I move to working with the GDM loader?
So is a serialized system represented as a folder then?
A serialized system is a JSON and a folder essentially. A JSON file and a folder that consists all the time series profiles.
Got it.
And some metadata associated with that series, yes.